Yeah, so I'm going to tell you something about our national activities here in Finland, what's going on around IoT, to give you an overview what's happening here. I will give some background information, then I try shortly to categorize IoT. Probably most of you are very familiar with that already. Then list a couple of challenges we have here, but of course also in other countries. And we will also show you some selected program activities, like some of the demos that we have here, and list some of our achievements. And this presentation will be a joint presentation. The first part I will do, give you some general overview, and the second part will be presented by Professor Sasu Tarkoma from University of Helsinki, who gives you a little bit technical background, what is happening in the program. And the way of working in our IoT program is basically as follows, like partners from the industry and various universities here in Finland are working together. And we have defined a couple of work package teams, and each team is led by someone from the industry, some partner from the industry, and jointly with some partner of a university. And we have defined all in all like 7 work packages that are relevant for the IoT work. And our entire program is scheduled to be 4 years, eventually even 5. We get some funding by the Finnish government, and we started beginning of 2012. Yeah, our way of working is that we are working in an agile way. We are having several sprints per year, 3 sprints, and we have defined that we can change our strategy of what we are researching, of what we are demoing, on a every 4 months, basically. So we are replanning our activities quite frequently to make sure that we are always researching the latest that needs to be researched. And all in all, we have like more than 250 experts in our team, and our budget is roughly 50 to 60 million euros. And all in all, we have like 35 consortium partners. They are here from Finland. Some of them are international companies, but we also have partners which are not part of the consortium, but they are just our participating in some of our events, for example. So from the big companies here, you see on the left-hand side the bigger companies, in the middle the SMEs, and on the right-hand side the research organizations. As you see, there's a couple of international companies, but maybe also some that you never heard before. I don't really want to go into detail on this one, but what's more important is that we have the vision that Finland and the Finnish ICT industry shall be a recognized leader in the IoT domain, and we have actually quite good prerequisites for that, because as you know, in Finland there's a lot of telecom operators, telecom companies that are interested in this field, and traditionally, due to Nokia and other companies, we're having quite the right experts here in Finland. And of course, also on university level, we have very good experts working together with us. So there's probably 100 different definitions what is IoT. My definition I like to use is, okay, it's about uniquely identifiable objects. And in our everyday environment, there is like 10,000 of objects, and some of them are important, some of them are not. And the big question is actually, should we connect everything, or should we only connect some parts of them, or should we connect nothing? then there's questions about security. Okay, if we connect this everything, then who else knows that we are doing that? Who else can spy on me? Let's say like this. But it doesn't make really sense to connect everything, but it makes sense to connect those things that have some kind of importance for us. And okay, what we are actually trying to do is to build a world where we have things with physical and virtual attributes, and hopefully these things or different kind of sensors will in future be integrated to the internet and in a way seamlessly interact with us, which means we don't really want to press a button or tell a machine to switch on. We want things to happen around us like we are used, let's say when we go to a shop, we are used that the shop door is going to open automatically. And in a similar manner, we would like IoT devices to interact with us so that we are not feeling disturbed by it, but we are just knowing that something is going to happen if I'm here in the room with certain devices. And what's very important is that we are using standard communication protocols, which means that standardization is very important for IoT, not only in Finland, but worldwide. And we also need to agree on a set of key technologies where we say, okay, this is the set that we define and we want to improve it. And okay, we have some of the technologies already out there, like RFID tags or the Web of Things or ubiquitous computing, like, but it's important that we focus on those protocols, those technologies that are worldwide used and not only in a small domain. And as you probably know, there's a big set of protocols that are already used, like from the old times, from internet and telecommunication. But in addition to those old protocols, there's now also those protocols that need to be further developed in the standardization fora, like, for example, CoAP or ZigBee. And in our consortium, we are quite active, and we have quite many members who are actively influencing the standardization efforts worldwide. So, big question, should we connect everything? And here I'm taking a few that I read at one Ericsson website, and that's the company I'm working for. And it basically says that it doesn't really make sense to connect everything, but it only makes sense to connect those things where we benefit from a connection. And all the other things we can forget, and they can be as they were always, all the years before. And we are not trying to connect everything just in order to connect it, but we are connecting the things in order to achieve something, to improve the world, to improve our interaction, our way of dealing with everyday issues. And as you know, urban population is growing, so there's a lot of problems in different kind of societies, especially in the third world countries, problems related to energy, transport, pollution, safety, and many others. And we believe that by our activities we can influence what's going to happen in future, not only in Finland, but by doing the base research also worldwide. And key question, okay, how we can really improve our life and other people's lives who do not have the ability to develop, for example, IoT. Yeah, and this is now one attempt how we can categorize the IoT. You could say, okay, it's categorized as tagging things, sensing things, and embedding things into existing other things. And there's quite many challenges to do that because, as you know, Sometimes it's even a challenge to connect a television set with a video recorder. And that's just a very standard thing that should work already centuries probably. In the Internet of Things, we will have tens of thousands different devices, and therefore exponential options of what can go wrong by connecting different things. So again, standardization is one of our key issues that we try to handle, and we really try to be active in this field. Other challenges is, of course, IoT is relatively young, so we really have still some things to learn. And one of the big problems is that development is unfortunately still in silos in many companies. I will explain that a bit later. And we also need to make sure to be compatible with other technologies. And we also need to see, okay, how much energy do our devices actually utilize? And the main problem is, if in a room like this, there would be, let's say, 50 devices that are measuring something like the light or the temperature or how much CO2 is in this room, all these devices would normally need to be connected to electricity. But in real world, you don't always have an electricity plug. So in the real world, there will be a lot of devices. They will have some battery. And batteries have a very limited lifetime. So part of our research is also going in that direction. How can we increase the battery lifetime? And we have some very interesting results by just fine-tuning our protocols that we are using, for example, for different kind of IoT nodes. We are able to increase the lifetime of any object, like not only by 10 times, but for example, by 100 times. And so it could be that an object that would have a lifetime from 1 month could probably last for 10 years due to the research we have done in that area. And okay, we are trying to be quite open to all the sectors that want to participate in our program. So, but we have divided it internally into intelligent environments, natural resources, and vitality of people. And one of the key questions is, of course, also how can we make money with what we are actually doing here. So we have dedicated a whole work package to deal with this issue. An IoT ecosystem only makes sense if you can generate revenue from it. And we have also done some research regarding, okay, where is it most expected that we make a lot of money, or where's potential for money? And here in the studies we have seen that the biggest potential is in the automotive industry and in the consumer electronic market. So this is really much higher than any other fields. But there's also fields where there's still a lot of research, for example, in the healthcare sector. And considering, especially in Europe, that we have a lot of elderly people and people who soon go to pension, I also expect this area to be very interesting for companies in the future, for IoT devices for elderly. And there's a big amount of different programs going on here in Finland. I will not go into detail for each of the programs, but here you can see a list. We look into the health and well-being, in the environment, in the forest cluster, then different kind of production like metal products, and also, of course, the traditional ICT industry. And we are not operating in all of those red boxes here, but we are open to any partner, national or international, who is operating in one of these areas. of course, at the moment, we are, for example, active in smart cities, in new energy, in safety, education, and more. But the interesting thing in our program, we are open for any kind of partner who wants to join us, and so far we have always found common ground between universities and companies who want to work together. Yeah, and one of the main challenges, of course, how we can create revenue, how we can make money in future with IoT. All the technical aspects are very interesting and they are very promising, but as long as we cannot make money, it does not help the companies and the economy. So we need to find business enablers for IoT businesses. And of course, our internal goal here in Finland is also to improve our international visibility. And as I said earlier, like standardization is one of the really most important things that on a scientific level, this is really needed to be successful internationally. Like it does not help us if we have a Finnish solution, we need a solution that works worldwide. Yeah, and as I promised earlier, I said something about silos. So at the moment, the main problem is we have different kind of industry sectors, and those sectors, they have their own solutions. They probably already work with IoT, but what is actually missing is a kind of common platform where different kind of industries could use that kind of platform independently on which kind of business the vertical sector is doing. And that's something where we are very active. We have already a couple of different platforms that are used by our consortium partners, and my colleague will later show you some of the real-world examples of what we have already on the market or under development here in Finland. Yes, and by that I would like to give the microphone to Sasu Tarkoma, professor from University of Helsinki, and he will give you the technical view about our project.
Okay, thank you for the introduction. So good afternoon. And now I will continue and tell you a bit about our approach. So how do we go from the silos towards this common platform and basis, and then the ecosystems. And our approach is based on kind of two directions. So basically we have the bottom up. So we start from trials and deployments and the real life, and then work towards the optimized solutions. And then we also have this top-down approach in which we brainstorm and have new ideas, maybe some kind of radical ideas, and then start to work on those and develop the technology. And of course, it takes longer time to take those ideas into deployments. So two different directions that then need to meet in the middle. And that meeting ground is now the common basis and platform. Right, so we have trials going on. So we start now with the bottom-up approach. And through the trials, we get this very important real-life knowledge that how the IoT technology works today, what are the limitations and the possibilities. And of course, we know that there are a lot of protocols, a lot of solutions already available, and we utilize those, and we of course extend and improve the existing ones. And then we also develop new ones, which are then a bit more radical than the existing ones. For example, information-centric networking provides new solutions that are not yet deployable, but in the forthcoming years we expect that yes, those will be deployable. Right, and this protocol suite or architecture consists of various components. So of course we have the wireless technologies, we have IEEE wireless techniques, we have LTE, we have 5G, and various near-field communication protocols. So we are using those and extending them as well. For example, we have been doing quite a lot of work with LTE and making LTE suitable for IoT devices. there especially the energy consumption is very challenging, and we need to optimize LTE to be a really low power protocol. Then we have the networking angle, and there of course IP version 6 is the key protocol. We're building on that. On the transport level, we have TCP, UDP, and TCP enhancements. Those are very interesting and relevant. And then on the higher level, we have protocols like CoAP, Constrained Access Protocol. We have MQTT, WebRTC, SPDY, and so on. So lots of different techniques. And we have been focusing quite a lot on CoAP, which seems to be a promising protocol for IoT deployments, also MQTT and these other protocols as well. And now, given the trial, the deployment, we of course need to choose what components, what protocols to use, and kind of consider the scalability demands and efficiency requirements and so on. And we have been doing that. In addition to this basic protocol stack and architecture, we have other components. We have, for example, gateway components which bridge these trial environments into the backend, the cloud backend. And these gateways can perform various functions for the IoT devices. For example, they can aggregate information, they can schedule signaling in the IoT deployment, and so on. And gateways are an important element for distributing state and the control functionality. Then we have the backend, and this is usually in the cloud, where we have various adapters for actually converting and accepting this data from IoT deployments and then mediating that wherever it's needed. And there we have various added value components and services as well that act on the IoT data. And we have multiple instances of these, so we expect that there are a number of these different cloud IoT hubs that then process IoT data and then enable third-party services to be built on top of this. And the data typically flows from these IoT deployments towards the cloud, but of course there is also the control element that we make intelligent decisions based on the data we get, and we control elements in the IoT deployment. So the control angle is also very important. And now to make this possible, we need to have this optimized protocol architecture. We need to have the higher level toolbox for processing IoT data. This includes various middleware components, and then we need to have this backend, various instances of that. And so we have the machine-to-machine and IoT traffic coming from the deployments, and this traffic is very different from the normal smartphone traffic, for example. It's uplink heavy and it's quite regular, typically. Very different from smartphones, which are downlink heavy. And then we have this processing of the data from low-level processing to high-level processing. And of course, we get value from the data when we do this processing and we aggregate the data. For example, consider a smart home from which you get energy consumption data and security data and so on. So we can all kind of combine together and have this unified view to the environment. And then we have the ecosystems which then are created on top of all of this. And we expect that there will be several ecosystems on top of this technology. Right, so this gives you a view that how we are approaching this IoT domain. Now, in practice, we do this, of course, through a specific organization. So we have teams in work packages addressing these different challenges and developing the solutions. And our approach here is fairly typical. So we have work packages and then cross-work package activities. And the key work packages are as follows. So we have, of course, the networking and communications. So we look at the radios and networking issues, also lower level security issues as well. We have the management angle. So we have a work package on that. And there we address this configuration of the network and how we manage the overall deployments. Then we have a work package on middleware issues and how to support the developer. So various APIs and middleware components are needed, for example, for semantic interoperability, for data dissemination, etc., etc. So lots of different things. and we have quite a lot of activity there. Then we need to also keep in mind the consumers, the end users of IoT, how people will see these IoT deployments, the IoT services, how to take users into account, and we are addressing this with the human interaction team, and there we develop visualizations. For example, consider the home environment. We do a 3D model of that, and then we can map real-time the sensor information from the home to this 3D model of the home. And then users can interact with this model. So that's one way to visualize these IoT deployments. Also, usability is important. So how do we really make IoT products that are easy to use? We are addressing also this requirement. Then we have the ecosystem. How will the ecosystems form? How will they evolve? What are the business models behind the ecosystems? And this is a very important part of our program, and we have various activities pertaining to this ecosystem modeling and business modeling. And there is a recent technical report summarizing the key findings of the first year, so you can find this report through our website. Then we also have the trials and demos, and I already introduced the basic idea there to be bottom-up, to really understand the real-life constraints, limitations, and we have various trials going on pertaining to IoT, and later Professor Heikki Ailisto will tell you about these deployments in more detail. Right, so now I will provide you some selected achievements during the first year of the program. So in order to go towards our vision, we have been doing quite a lot of scientific dissemination and also standardization contributions. And during the first year, we produced or published and submitted about 70 scientific articles. And we have been mainly publishing with IEEE forums, so IEEE conferences and journals, but also some other forums as well. And here you see some key forums to which we have submitted and in which we have published scientific results. And in addition to the scientific dissemination, we have been doing quite a lot of standardization work, and here mainly IETF, Co-op working group and HomeNet working group have been our prime forums, as well as IEEE, and there especially this 802.11ah working group, and then LTE at 3GPP. So these have been the key standardization aims for us. And for example, for LTE, we have very nice results on energy efficiency, how to improve LTE for IoT from this energy consumption point of view. Regarding research and prototypes, here we have been doing these components, these enablers needed to build this common basis, the platform, and to support the trials. So here we have been working with different security solutions. We have been working with Co-op, also Co-op protocol interoperability. Interoperability is of course very important. So the deployments need to talk with each other, and we really need to have interoperability to go around the silos. Also, we have been looking at various constrained environments, for example, snow environments. That's of course very specific to Finland. We have a lot of snow, so it makes sense to do various experiments there. Then various surveys on state-of-the-art in machine-to-machine and IoT, and then extending the state-of-the-art solutions, especially from this energy point of view. So energy has been one of the key targets for us, addressing the limited battery capacity of the devices. And then one highlight I want to mention is this world's first implementation of the IETF HomeNet technology. So HomeNet enables to bootstrap home networks very easily. So it's kind of zero configuration approach to networking. And we have the first implementation of this. About the visualization, so here you see an example of this 3D home I mentioned. So we have this 3D model, and we get the sensor data, and we can then map it to this model. And then users can interact with the model and see, for example, that how much electricity the home is consuming and how the electricity is distributed across the home. Also, we can see the lock status and so on at home. And then, of course, we can interact with this model. For example, open the door and set the temperature and the humidity and so on. So it appears to be a very useful approach in presenting IoT to consumers. Then considering the ecosystems. So one question for us is that how are these ecosystems going to form? So what are the seeds for the ecosystems? And now we are at the second year of the project, so now we are really considering the ecosystem formation. And I will very briefly give you some starting points, some seeds for our ecosystems. So one area is this vehicular networking, and there we have Renaissance Mobile pioneering this area, and we have the connected car scenario. So cars talking with each other, cars talking with fixed infrastructure, and this is a very rich domain to build applications. Then we have the home environment, and there we have the Dare Gateway product, and you will hear later more about this. And the Dare Gateway, it monitors the home environment, the electricity consumption, temperature, and various other parameters at home. And then we can now expand on this and combine this with other products. For example, there is a Finve key-to-phone product which can be used to control locks and access to facilities. So we can now combine these to form a kind of basis for an ecosystem. So we can gradually work towards this bigger and bigger working context and more APIs that we can use. And now, for example, based on this, we can create a visualization with the real-time information about the home, including the locks and access control. So that's a very interesting direction. Then we have the Ericsson device connection platform. This is an API and a platform for managing machine-to-machine connections. So we can provision machine-to-machine communications with this approach. And it's one seed for us for an ecosystem. Then we're also looking at high-definition positioning. This is, of course, very relevant. And although there are quite a lot of research results in this area, there are few products available. So indoor positioning is really one very promising direction for building an ecosystem and really getting the actual commercial deployments going. Then also I want to mention the state-of-the-art report. So this is now available, and it summarizes current understanding on the evolution of the IoT market, which sectors will evolve and then how. And actually there Wilhelm showed you very briefly the cover of the book, so it's now available. Please have a look at that. Then also regarding this vehicular area, we have a pilot going on at Tampere, which is about intelligent traffic, and there are different public cars and buses instrumented with sensors, and we get information about road conditions and traffic situation and so on. And we can then create a user interface with this information to help people plan how they use the public transportation and also what's the congestion situation, for example, at the roads. Very interesting direction. Right, so I now gave you a brief glance at what kind of activities we have. This was just a small subset of what we are working on, and you can find much more information in our Internet of Things magazine, and this has been distributed to all IoT Week participants, so please have a look at the magazine, and you can also find this at our website, and it contains many more results and bits of information about what we are doing at the moment.